Take the exact same piece of steak, same cut, same grade, same weight. Cook one in simmering water and the other in a screaming hot cast iron pan. You get two completely different foods. One is gray, soft, and flat. The other is a mahogany-crusted, smoke-edged, deeply complex piece of meat that smells like everything you want dinner to be. The only difference? A single chemical reaction. And once you understand it, you will never cook meat the same way again. Welcome to the Meatz. Today we are going deep on the Maillard reaction, the most important chemical event in all of cooking. By the end of this video, you will know exactly what it is, how to trigger it perfectly every single time, and, this is the part most home cooks never hear, what actually kills it without you even realizing. Stay with me, because that last one is a game changer. So what exactly is the Maillard reaction? At its core, it is a chemical interaction between amino acids, the building blocks of protein, and reducing sugars, triggered by heat. French chemist Louis-Camille Maillard first described it in 1912, but here's the wild part. He was not even studying cooking. He was researching how the human body synthesizes proteins. He had no idea he had just explained why bread smells incredible fresh from the oven, why coffee has that deep roasted complexity, and why a properly seared steak can stop a conversation at a dinner table. The reaction that defines great cooking was discovered by accident. Now here's where it gets genuinely mind-bending. The Maillard reaction does not produce one or two flavor compounds. It produces hundreds. Some estimates put it at over 1,000 distinct chemical compounds depending on the ingredients involved and the temperature reached. And those compounds do not just add flavor, they create color, aroma, and texture simultaneously. That mahogany crust you are chasing is not just beautiful, it is the physical evidence of hundreds of flavor molecules forming in real time right on the surface of your meat. But here's the thing, and this is the first open loop I want you to hold on to. The Maillard reaction and caramelization are not the same thing. Most people use those words interchangeably, and it is one of the most common misconceptions in home cooking. We'll get to exactly why that distinction matters in just a moment. First, let's talk temperature. The Maillard reaction kicks off at around 280 to 330 degrees Fahrenheit. That's roughly 140 to 165 Celsius, but it really accelerates above 300 Fahrenheit, which is around 150 Celsius. This is why boiling water, which maxes out at 212 Fahrenheit, can never produce a sear. Water simply cannot get hot enough. The moment you drop protein into a water-based environment, you have locked yourself out of the Maillard reaction entirely. Your food will cook, but it will never brown the way it needs to.
That is the science behind why every serious chef obsesses over dry heat cooking methods: cast iron, grilling, roasting, broiling. You need direct, dry, intense heat to get those temperatures high enough to trigger the reaction. Now back to the caramelization question, because this is one of those details that genuinely makes you a better cook when you understand it. Caramelization is a separate reaction. It involves only sugar breaking down under heat, no protein required. It starts at much higher temperatures, around 320 Fahrenheit for fructose and up to 375 for sucrose. The Maillard reaction, by contrast, requires both amino acids and reducing sugars working together, and it starts earlier. So when you are searing a ribeye and you see that crust forming, that is primarily Maillard. When you are caramelizing onions low and slow, that golden sweetness is a mix of both reactions, but it is Maillard doing the complex flavor work first. Two reactions, two different mechanisms, and knowing the difference tells you exactly what temperature and what ingredients you need to make either one happen. Here is your pitmaster's tip for this video, and this one is genuinely exclusive knowledge that changes your sear game immediately. Moisture is the enemy of the Maillard reaction. When the surface of your steak is wet, the heat energy from your pan goes into evaporating that moisture first before it can raise the surface temperature high enough for Maillard to kick in. Your steak essentially steams instead of sears. The fix is dead simple. Pat your meat completely dry with paper towels before it ever touches the pan. And if you want to go even further, salt your steak uncovered in the fridge for at least an hour. Overnight is better. And that salt draws out surface moisture, which then gets reabsorbed, seasoning the meat from within and leaving the surface genuinely dry. Dry surface plus screaming hot pan equals the sear you have been chasing. Now here is the escalation, the part that took me longest to really internalize, and it is the reason fine dining kitchens produce a sear on a piece of wagyu or dry-aged beef that tastes categorically different from what most people achieve at home. It is not just about the temperature, it is about the composition of what is being seared. Remember those hundreds of compounds the Maillard reaction produces? The exact compounds that form depend on which amino acids and which sugars are present in the meat.
And this is where dry-aged beef and high-grade wagyu genuinely change the game. During dry aging, enzymatic breakdown concentrates the amino acid profile in the meat surface. The sugars present shift. When that aged surface hits a hot pan, the Maillard reaction has a richer, more complex palate to work with, and it creates flavor compounds you simply cannot get from a fresh, wet-aged cut. That nutty, almost umami-forward crust on a properly dry-aged steak is not magic.
It is the Maillard reaction working with better raw ingredients. This is why every serious fine dining steakhouse dry ages their beef. They're not just tenderizing, they are pre-loading the surface for a more complex sear. So how do you apply all of this at home right now? Start with a dry surface, non-negotiable. Get your pan or grill surface genuinely, dangerously hot before the meat goes on. Use a fat with a high smoke point. Refined avocado oil or clarified butter handles the temperatures needed without burning before Maillard can happen. Do not crowd the pan, because multiple pieces of meat release steam and you are back to the same problem as water. Let the meat sit without moving it for the first minute or two. You need continuous contact and consistent heat to build that crust. And if you are after fine dining level results, invest in a cast iron pan or a carbon steel pan that retains heat aggressively when cold protein hits it. Thin stainless pans lose temperature too fast, and the crust suffers for it. One last thing, and this is the detail that brings everything full circle. The Maillard reaction also creates the aroma compounds that hit you when you walk into a great steakhouse. Those volatile molecules are literally a byproduct of the same chemical process happening on the surface of the meat. Smell is flavor before it enters your mouth. When a seared steak smells extraordinary, it is because the Maillard reaction has been executed correctly. The sear you see, the crust you taste, and the aroma that fills the room are all one single chemical event. That is how powerful this reaction is. It creates an entire sensory experience from a single process. If you've been getting gray, flat sears at home, now you know exactly why and exactly how to fix it. Dry the surface. Get the heat right. Give it time and contact. And if you really want to take it to the next level, start experimenting with dry-aged cuts, because once you sear a properly aged piece of beef, you will understand immediately what we have been talking about today. Drop a comment below and tell me, what cut are you planning to sear first with this knowledge? I read every single one. If this video upgraded your cooking, hit subscribe so you never miss a drop from the Meatz. And next time, we are breaking down the reverse sear method step by step and why it might be the single best technique for thick cuts that most home cooks are still sleeping on.